So first I'll do the question from the questionnaire set that I had shared in the WhatsApp group. Okay, if anyone is not in the WhatsApp group, it's there in the description of this live, so you can join the group from there. And I'm doing question number 10 most probably, as far as I remember it is question number 10. I'm doing that first, then I'll do the rest of the questions, and then we will be doing questions from rank in today's class mainly. Okay, so this was the question that people were facing problem with, that given a matrix M cross N and B matrix N cross M. Now one property stated that identity plus AB and identity plus BA are both equal. Okay, identity plus AB and identity plus BA are both equal. Using this property, you need to find the determinant of the matrix. Now many people were telling me that they can find the value of the determinant using normal expansion method. But how to utilize this property which is given? Because if you're utilizing the property, your answer will be done in like 1 minute. But if you are doing the normal determinant, then if you have to break this determinant, it's a long process. Okay. So the question is how to utilize this property. See, it is told that identity plus AB, let's consider AB is in this format. Okay, so identity plus AB is this. I need to figure out then what will be BA. Or first let me figure out what is AB. Okay, so from here AB would be this given matrix, which is 2 1 1 1 1 2 1 1 1 1 2 1 and 1 1 1 2 minus the identity. Obviously it is saying that identity will have the same index as that of AB. Now AB, I can see AB is a 4 cross 4 matrix, so the identity should also be a 4 cross 4 matrix, otherwise subtraction will not be possible. So identity is going to be 1 0 0 0 0 1 0 0 0 0 1 0 0 0 0 1. Right. So if I do this subtraction, I will be getting my AB matrix as 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1. I think up till here most people have done it. Now the problem is, what will be the A matrix and what will be the B matrix such that their product will create this matrix. This is where you have to think little bit outside the box. Okay. So here, if you little bit try to visualize that I can write this as a product of two matrices in this format. If I take the product of these two matrices, column wise one, row wise one. Now this is a 4 cross 1 matrix and this is a 1 cross 4 matrix. So obviously if you multiply them, you are expecting a 4 cross 4 matrix, which is this matrix. Now you can do this multiplication. You can check 1 into 1, that's 1. Again 1 into next one, that's another one. So you'll get a matrix which has all entries as 1 and it is going to be a 4 cross 4 matrix. So from here you get an idea that this is supposed to be your A matrix and this is supposed to be your B matrix. Now comes in the property. Now the property is telling me that I have got AB. Okay, now the property is telling me that this I plus AB will be same as I plus BA, provided I will have that same order as that of AB and over here I will have the same order as that of BA. Okay. So I plus AB, I am not concerned with this one now. I am concerned with the I plus BA right now. So now what will be B into A? So this is my A, this is my B. If I want to find out BA, that will be row wise 1 1 1 multiplied with column wise 1 1 1. Here the multiplication becomes interesting. Here this is a 1 cross 4 matrix and this is a 4 cross 1 matrix. So if I multiply 1 cross 4 with a 4 cross 1, I will be getting a 1 cross 1 matrix. That means a single element answer. So this multiplication, I am expecting my answer to be a single 1 cross 1 matrix. And if I do the multiplication, 1 into 1 plus 1 into 1 plus 1 into 1 plus 1 into 1, that will be how much? 4, right? So this is a single entry matrix or a single value whose value is 4. So now as I told that identity will have the same index as that of BA. So BA is a 1 cross 1 matrix. So that means identity also has to be a 1 cross 1 right now. So a 1 cross 1 identity is an element which only has the entry 1, right? If identity 1 cross 1 is 1, identity 2 cross 2 is 1 0 0 1, like this it goes on. So 1 cross 1 identity is 1. BA is how much? BA is 4. So if you add them, you get 5, right? So now the question is saying that you have to find out the determinant of the matrix of this I plus AB matrix. You have to find the determinant of the I plus AB matrix. Okay. So we have got that I plus AB is equals to the element 5, which is the 1 cross 1 matrix. So now determinant of I plus AB is going to be the determinant of the matrix 5, which is 1 cross 1, the determinant of this single element. The determinant of a single element is the element itself. So the value over here, that is going to be how much? 5. So 5 is the answer to this question. Okay, so this was the logic behind this question. Okay, so I hope this answer makes sense to you. Come on, tell me in the comments, did you understand the process? Yes, no, please let me know. Okay. So now moving on. So this was the question which you had problem from the questionnaire set. Now moving on to some random questions on matrix determinant. After that, we'll start rank a little bit later. Okay. So let's do this question. This is EC 2025. It is saying that any two columns of a determinant, are interchanged, then which of the following statement is correct? Okay. So first I want you to try the answer. Okay. Simple, very simple question. If two columns are interchanged, doesn't matter what the matrix is. Two columns interchange, what is the effect? Tell me the answer in the comment. What do you think? Which option should be correct? The elements are not important over here, just the property, interchanging of two columns. Yes, option A is correct. See, if we interchange two columns, what happens? We get a minus sign. Absolute value means the mod value. So the mod value is not changing. If there is a minus sign, mod value remains same. So absolute value remains unchanged, but sign will change. So the sign of the answer is changing. Okay, if the answer of the original determinant is, let's say, 5, then after interchanging the columns, the answer will be minus 5. So that means absolute value is same, but the answer is changing just with a negative positive sign. That means just a sign change. Okay. So simple question. Next, now I want people to answer this question without breaking the determinant. Just by looking at the determinant, you should be able to tell me the answer. First of all, tell me the answer and tell me what is the property you are using to tell me the answer. Okay, both things are important. I don't want you to break this determinant at all. Just by looking at the question, you should be able to answer. Yes, option C, that is correct. Option C. Now, can you tell me how are you saying option C? What property are you using to directly answer this question? What is the property that is getting used over here? I will wait for someone to write. What property are we using? Yes, lower triangular matrix. Yes, correct. Correct. So, lower triangular matrix. Okay. So, this is a lower triangular matrix, and we know lower triangular matrices, the determinant value is equals to product of the diagonal elements, right? Lower triangular matrix, so product of the diagonal elements, determinant value is going to be just that. So product of the diagonal elements is 1 into 1 into 1 into 1. That is how much? Simply 1, right? So simple application question. So the numbers could have been something else other than 1 also. Doesn't matter. The answer will be same. Okay, next, this one. So this is again a pretty easy question. I want you people to try before I answer the question. Very simple. Okay, someone is saying your lectures are better in YouTube than in college. See, this comment directly answers the student mentality. The thing is that in YouTube you are paying attention, in college you are not paying attention. Because I am the same person who is delivering the same content in YouTube and in college. In college you are not interested to listen. In YouTube you come here just to listen. So that makes all the difference. Okay, because I am the same person who is teaching the same thing here and there. So it is not possible that I am teaching good here, I am teaching bad there. I am teaching the same thing. The problem is you are listening here, you are not listening there. So this answers the question of this entire generation right now. Okay, let's get back to the question here. Tell me, what should be the answer? This question doesn't need to be completely solved. Okay, you can answer this question just with some little information. See, we all know that if we are finding inverse of a 2 cross 2 matrix, if we are finding the inverse of a 2 cross 2 matrix, okay, inverse, specifically 2 cross 2 matrix, A, B, C, D. If this is A matrix, then A inverse is going to be, we don't need to do the adjoint and all those things. Just remember that the diagonals will interchange each other. The principal diagonal elements will interchange. The off diagonal elements will be multiplied with a negative sign. Just the sign will get inverted and you have to divide by a determinant. So the answer we can say is directly 1 by determinant of this matrix, which is going to be AD minus BC, and the matrix is going to be just interchanging these two things, that is D into A, and multiplying these two with a minus sign. So that means minus B minus C. So this is the direct way method of finding inverse, provided it is a 2 cross 2 matrix. If this is 3 cross 3, then such shortcut will not work. Okay. So one thing we can observe is that if we are interchanging the elements, then this element is supposed to be over here, right? Let's forget about determinant, everything else. So this position in the inverse, this position should have the element 4 plus 3i. So I can see 4 plus 3i is only present in this particular option. Rest all the options in this position we have different values. So we don't need to do anything else. Directly we can say option A is correct. We don't need to find determinant. We don't need to do any other thing. Just track one position. If suppose some other option also had 4 plus 3i in that position, then you need to see what is happening to the other elements. But with just 4 plus 3i, we can see nothing else is matching. Only option A is matching. So that is correct. Simple. Okay. All right. So moving on to next question. Okay, again, I will wait for you people to answer this. Carefully observe how the elements are being generated. From there, you have to conclude your answer. Okay, let's see who can answer this question. Let's wait for some more answers. Come on, this is not very difficult. This should be an easy question. Just figure out how this formation is working. I comma jth position, the value of that position is given by I minus j whole cube. So figure out the values, and the moment you get the matrix, you should be able to answer. Okay, where I can see very less participation in this answer. Let's see what's the problem. It's a 3 cross 3 matrix. So in general, a 3 cross 3 matrix is written in the form A11, A12, A13, A21, A22, A23, A31, A32, A33. Right? So for the first element, ij is how much? Ij is 1 1. I and j is 1 1. So A11 will be 1 minus 1 whole cube. Okay. 1 minus 1 whole cube. That means simply 0. For the next one, it's 1 2. So 1 minus 2 whole cube. Okay. So 1 minus 2 whole cube, that is minus 1. Then next one is 1 minus 3 whole cube. 1 minus 3 is minus 2. Minus 2 whole cube is minus 8. Okay. Then coming to this position, 2 1. So 2 minus 1 whole cube, that is 1. 2 minus 2 whole cube, that is 0. 2 minus 3 whole cube, that is minus 1. 3 minus 1 whole cube, that's 8. 3 minus 2 whole cube, that's 1. 3 minus 3 whole cube, that's 0. So you can see this is definitely a skew symmetric matrix because its principal diagonal is 0. That's the first requirement of a skew symmetric matrix. And secondly, you can see this position, if you multiply with a minus sign, you get this value. This position you multiply with a minus sign, you get this value. This position you multiply with a minus sign, you get this value. So basically this is satisfying A transpose A equals minus A transpose, which is the symmetric property. Sorry, skew symmetric property. So that means this is a skew symmetric matrix. Right? Simple. Okay. Next question. So it is given that this is a symmetric matrix. You just have to find the value of K over here. So use the concept of symmetric. Symmetric was A equals A transpose. Use this property and try to find out the K value. Okay. Like in the previous question, the cross diagonals were equal but change of minus sign. In symmetric, what happens? The cross diagonals are always equal. Right. So just use that concept and tell me the value of K. Yes, correct. Option B. So if it is symmetric, then this value and this value must be same. So that means 2k plus 5 must be equals to 3k minus 3. So k equals 5 plus 3. No, that's option B is wrong. Sorry, option B is not correct. So k equals 8. Not option B, option A. Right? K equals to 8. Okay. 2k plus 5 must be equals to 3k minus 3. So if you just change sides, k equals 8. Okay. Simple question. Next. Let's see who can do this question, because this you will not get the answer directly. You have to do something to get the answer. Let's see who can do this. It is saying that you have to find the value of x and y such that the determinant is 0. So the question is simple. You understand what to do. You have to take the determinant, set it equal to 0. From there, find x and y. Okay. The problem is you will get one equation. From there, you have to solve for two variables. Let's see who can do this. It shouldn't take more than 2 minutes. Okay, let's put 2 minutes in the clock. Okay, 2 minutes timer. Let's see who can get the answer in 2 minutes. Okay, so I have got one answer as option B. Let's wait for a few more answers. Let's see who else can solve this. All right, so we are getting option B, right? So that's correct. So what we can do is simply do the determinant x13, y26, 357, and there are two ways of doing this. One is by using a rank concept and one by really doing the determinant. I'm not going to the rank concept, but if we use the rank concept, it's basically going to be more easy because I can see just multiple of 2, 1 into 2, 3 into 2, 6, multiple of 2 is there. So rank concept would have been easier, but I'm not going into that because I'm not done rank yet. So I'll just go by the determinant process. So if I break the determinant, I will have x times 14 minus 30 minus 1 times 7y minus 18 plus 3 times 5y minus 6 equals 0. Right, so this is minus 16x, that's minus 7y plus 15y, so that's a plus 8y, and we have 18 minus 18, so that's 0. So if I can take 8 common, so I'll get y minus 2x equals 0. So that means y minus 2x equals 0. So I am not directly getting xy value. Now what I can do, I can check with the options which option is going to satisfy this particular equation. So I can see that when x is 1 and y is 2, this satisfies this particular equation. So that means 1 comma 2 is the answer to this question. Okay. All right. So now let's go into the concept of rank so that we can do these kind of questions much more easier with the rank concept. Okay. So what is rank of a matrix? Let's take a small example if you have forgotten. Let's say I have the matrix 1, 2, 3 and 2, 4, 6 and 3, 7, 8. Okay. So what I can do is, or what I should be trying to do is, I should try to do some elementary row operations. Okay, will not involve any column operations, only row operations. We'll do some row operations to try to ideally bring this matrix in this format. This is our ideal target. We want our matrix to come into this format, but generally it will not come into this format, it will come into some other format, but this is our ideal situation which we want to achieve. Okay, so what we can see is this position has to be 1, everything else below it must be 0. So this position is 1, I need to make elements below it 0. For that, whatever row operation is required, I will do. So I need to make this 0 and make this 0. So that means I need to do the row operation. R2 dash equals R2 minus 2 times R1, and R3 dash equals R3 minus 3 times R1, and that will be 1, 2, 3. If I do the subtraction, so it's going to be directly on 0, 0, 0. This is 0, 6, 7 minus 6, and that's 1. 8 minus 6, and that's it's 3 times minus. So 7 minus 6, that's 1. 8 minus 9, that's minus 1. So whenever we get a 0 row, completely 0 row, we'll try to put it down. Okay, we'll try to keep all the 0 rows at the bottom. So I'll just interchange these two rows. So interchanging them will make it 1, 2, 3, 0, 1, minus 1, 0, 0, 0. Okay, so now again, next question is, with this particular row, can I make this row completely 0? Can I make it completely 0, or can I just make some of the terms 0? That's the question. If some of the terms are becoming 0, something is remaining non-zero, we are not interested with that. We are interested with the question whether I can make all the elements in row number 2 0 with the help of row number 1. See, now it is not possible. It is not possible because of the location of 0. Okay. If I try to make this position 0 with the help of the 2, then I will end up destroying this 0. Okay, so if I try to make any position 0, I will end up destroying this 0. So that means I will never have a completely 0 row after this stage. So now the number of non-zero rows that are remaining, that is equals to rank of the matrix. So over here I can say rank of the matrix is going to be, rank is going to be 2. So I hope we all know how to find out rank. I am not much elaborating into that. I will go into the properties of rank. Okay, now the properties of rank is, if property number 1, if rank of a matrix is less than the order of the matrix. Okay, so in this case you can see, this is just the example of that. This is a 3 cross 3 matrix. Okay, so its order is 3, and rank is 2. So rank is less than the order. If rank is less than the order, then from here we can say the determinant of that matrix is always 0. If rank is less than order, determinant is definitely 0. So in this case, if we take the determinant of this matrix, it is definitely 0. Now again, important concept is that if I do determinant at any stage, it will remain 0. What I'm saying is that if the determinant of this particular matrix will be same as the determinant of this particular matrix will be same as the determinant of this particular matrix, because doing row operations never change the determinant value. Row operations don't change determinant value. Okay, so that means at every stage the determinant value is same, it is not changing. So at the last stage I can see, because rank has become less than order, rank is less than order means at least one of the row has become 0. At least one, more than one can also be 0. So if at least one of the row is 0, so obviously its determinant value is also 0. So the determinant, if it is 0 in this stage, so that means the determinant is 0 here also. So that means the determinant is 0 in the original matrix also. So from there we get this conclusion that if rank is less than the order, then definitely the determinant value is going to be 0. Okay. So now how much less than the order, that is not required. Rank can be less than order in any way. Let's say rank can be 1, order can be 3. Rank can be 2, order can be 3. In any case, determinant value is 0. Okay. And obviously, if rank is equals to order, then determinant is definitely non-zero. Okay. One more property, rank of product of two matrices. If I have product of two matrices, then we cannot directly say what is the rank. What we can do is we can say then the rank is less or equals minimum of rank A or rank B. Okay, so let's take an example. Let's say that rank, I have a matrix, whatever that be, let's say its rank is 2. I have a B matrix, whatever that be, let's say its rank is 3. Okay, now if I take A into, and let's consider these are all same order, 3 cross 3, 3 cross 3. So if I take AB matrix, that is also a 3 cross 3 matrix, whatever that matrix be, we can say that its rank must be less or equals minimum of rank A, rank B. It must be less or equals minimum of rank A, rank B. Now what is the minimum of 2 and 3? Minimum of 2 and 3 is 2, right? So I can say that rank of AB is less or equals minimum of 2 and 3 is 2. So we cannot definitely say what is the rank of AB. We can never say that. What we can say is the rank of AB will be maybe equal to 2 or maybe even less than that. Okay, so rank of AB is less or equals minimum of rank A, rank B. Now what we can say from here with guarantee, that is rank of AB will be never equal to 3. So one question we can get like this, that rank A is 2, rank B is 3, then can the rank of AB be also 3? Never possible, because the rank of the product has to be less than the minimum of the two ranks. Okay. Similarly, you can have another matrix ABC, then you just have to add another rank C, and so on. It continues. So if you have product of many matrices, then it has to be less or equals minimum of the ranks of each of the matrices. Okay, and then the final property, that rank of A transpose A is same as, so first let me tell you this property, the rank of A transpose and rank of A is same. Okay, if you do transpose, rank does not change. Okay, property number 4, if you do some row operations, okay, rank does not change. So any row operations you do to make the matrix more simpler, or you want to reduce the matrix to a more simplified version, rank never changes. Original matrix, whatever is the rank, after row operations, same rank. And number 5, rank of A transpose A is same as rank of A transpose, and that is also same as the rank of the original matrix. Now this is a very important property. I will do some questions based on this property. Just now I will do some questions. So if you multiply a matrix with its own transpose, from whichever side you multiply, its rank will be same as the original matrix, it will not change. So these are some basic properties of rank. Okay, now we will do some problems related to this. Any questions up till here? Come on, give me a yes, no answer. Any questions? Should I proceed to the questions? Yes, no? Okay. So moving on to some questions of rank. So just the property which I told you right now, these are all some previous year questions. I don't have the year written right now in this particular format, but these are all previous year questions of GATE. So it is saying that A is a 4x3 real matrix of rank A. Achha, one more thing I need to add, which I forgot. That is, this property doesn't always work. This property works only when the A matrix is a real matrix. Okay, that means if any matrix has complex numbers as its elements, this property will not work. Okay, it will fail, because product of I and I will create something that might reduce the rank. Okay, so this property, only particularly this property will work if it is real matrix. For the other properties, it is okay for any matrix, but only for the last one it will work if the matrix is real matrix. So now let's take a look at this question. See, that's why it's mentioned A is a 4x3 real matrix with rank 2. So that means rank of A is how much? Rank of A is 2. Which of the following statements is correct? Rank of A transpose A is less than 2? No. Rank of A transpose A is equal to 2. Correct. So option B. It is directly coming from the property which I told you. Okay, so this is going to be same as rank of A transpose A. Okay, so option B. All right. So this was a very simple application question. Let's do one more. Let's see who can answer this question. Okay. A matrix is, two matrices are given to you. It is told that rank of the matrix A is how much? N. Then what will be the rank of B? Okay. Let's see who can answer this question. Again, this should be a simple observation answer. Okay, that means you don't need pen and copy to answer this question. Just little bit observation, you can answer. Let's see who can answer. Come on. Use some observational skills. Try to figure out how this B matrix is getting created. Because if you look carefully, B is created with the elements PQRS, and PQRS is already present in A matrix. So doing something with the A matrix will create the B matrix. This should be the hint. Come on, waiting for some answers. So not getting any answers up till now. So I guess people are not being able to observe how the B matrix is getting created with the A matrix. Let's see what's the problem. If you look carefully at the B matrix, this should come to your mind. A is given by PQRS. So A transpose will be PQRS column wise. Okay. Now, if I multiply A with A transpose, PQRS, PRQS, I will get P square plus Q square, first element. Next will be PR plus QS, PR plus QS. Next will be PR plus QS again, PR plus QS. Next will be R square plus S square, R square plus S square. And if you observe, this is your B matrix, right? So I have got my B matrix by doing A into A transpose. So basically my B matrix is nothing but A into A transpose. Now we know rank of A is 2, so rank of A transpose, so rank of A is n, so rank of A transpose will be also the same, that is n, so that means option C. Okay. So just this observation was important, that B is created with A into A transpose. And we know rank of A is same as A transpose, but provided this is not a very good question, this is, I should say, this question, if someone challenges this question, then they will have to provide free marks, because it is not mentioned anywhere whether this is a real matrix or not. So here we are all assuming that PQRS are real numbers. What if PQRS are complex numbers? Then this property will not work. Then we cannot definitely say what is the rank. No one can say. It can be n also, it can be n minus 1 also, anything can be the answer. Okay, so this question is created assuming this property is getting satisfied. That means they are assuming A is a real matrix, but it is not mentioned anywhere in the question. So this is the fault with this question. Okay. Next, now this is direct question. You have to find the rank of the matrix. Direct question. So I'll just do this one direct question. Next questions you should be able to do on your own. So as I discussed before, how to find rank. First, with the help of this one, you will try to create the elements below it completely zero. So whatever row operations you need to do according to that. So I can say that R2 dash equals to R2 minus R1, and R3 dash equals to R3 minus R1. And if we do this, we are getting 1, 1, 1, 0, minus 2, minus 1, 0, 0, 0. Right? And now we can directly see that we cannot make any row 0 with the other row. We cannot make the second row 0 with the first row, the first row 0 with the second row, because of this 1, 0 which has occurred. Okay, if we try to make anything else 0, then this 0 will be destroyed. So we cannot make anything completely zero after this stage. So that means we can say rank is how much? 1, 2. Number of non-zero rows. So rank is how much? 2. Okay. So direct, simple question, simple answer. So now I want you people to do this particular question on your own. Okay. Again, direct question, simple question. You just need to find the rank of the matrix. Do some row operations and tell me the answer. Okay, I've got C as one of the answers. Anyone else? Okay, so people are saying option C. All right. So just see whether you are solving it the way I am doing. See, we don't want to use this 5 to make elements below it 0. We always want 1 because it is easy to work with 1. So always try to bring the 1 in the first row. Okay. So let's do the changing of rows. Let's bring the second row to the first row. So that will make it 1, 0, 2, 5, 10, 10, 3, 6, 6. Now with the help of this one, I want to make the elements below it 0. I want to make this one and this one 0. So I'll do the row operations. R2 dash equals R2 minus 5 times R1 and R3 dash equals R3 minus 3 times R1. So that will give me 1, 0, 2. If I do a 5 times subtraction, so that's 0, 10, 0 and 3 times subtraction, so 0, 6 and 0. Right, now what we can see is we can use this 6 to make this position 0, or we can do the other way also. We can use this 10 to make this 6 0, and none of the other zeros will be destroyed because the zeros are synchronized. 0 below 0, so zeros are synchronized. The zeros will not affect each other. So with this 10 we can make this 6 0. So how will we do that? We'll just do the row operation that R3 dash equals R3 minus, we want to minus, subtract 6 from it. So first I have to divide by a 10, multiply with a 6 and multiply with row 2. So 6 by 10 multiplied with row 2 will make this position 6. Now if I minus R3 minus this value, so that will be 1, 0, 2, 0, 10, 0, 0, 0, 0, and we cannot make anything else completely 0. So rank is how much? Rank is 2, right? So we get the answer to this question, that rank is 2, option C. Okay, let's do another question. Now this is a little bit bigger matrix, 2017 question. You have to find the rank of the matrix. Come on, let's see who can answer this. Just use this one to make things below it fully 0. You just have to make this position 0. That's it. So I will solve as you are also solving. So first we'll be doing R4 dash equals R4 plus R1. So that will make, I'll just do the changes right over here. That will make this position 0. This position minus 1. This will remain 0. This will remain 0. This will remain 1. So this is the change that will happen. Next, what else can I do to make things? So now the question is, can I make anything completely 0? I have to see that the 0 over here is not synchronized, or I should be able to tell like this, that what I can do further, I can use this one to make this position 0. Okay, So that will be easy to visualize things. So with this one, if I make this position 0, I will have 1 minus 1 0 0 0 0 0 1 minus 1 0. So what I'm doing is R4 dash equals R4 plus R3. So 0 1 minus 1 0 0 0 0 minus 1 0 1 and 0 0 0 1 minus 1. Okay, so this column has been sorted, only just a 1 in the top. This column is kind of sorted, okay, because below this one there is no non-zero element, but over here so this one is also sorted, because what I'm trying to observe over here is that, let's look at the diagonal elements. Below the diagonal we want everything to be 0. Below the diagonal we want things to be 0. So this column below the diagonal things are 0, this column below the diagonal things are 0, this column below the diagonal things are 0, nothing to do with these 3 columns, and this one, the last element is 0, so nothing to do with this one as well. And that's one extra column we are getting, because it's not a rectangular matrix. Or is it rectangular? Did I write anything wrong? Did I miss anything? 1 2 3 did I write anything wrong? 1 2 3 4 5 1 2 3 4 5. Achha, I have marked it in a wrong way. That means, right, I've marked it in a wrong way. This is the diagonal. Sorry, I marked the diagonal in a wrong way. This is the diagonal. It's a 5 cross 5 matrix, so should have a perfect diagonal. All right. So elements below the diagonal is 0 over here. Element below the diagonal is not 0, so we can do something about this one. Okay, we can do something about this minus 1. We can do something about this one also. But we don't want to do so much calculation. If we observe carefully that if I try to make this position 0, then I have to utilize this 1 over here. This minus 1, with this minus 1 I can make this position 0, but the moment I do that, I will end up destroying this 0. Okay, this 0 will get destroyed because of this 1. So if I try to make this 0 is getting destroyed, so that is not working out. If I try to make this position 0, let's say with the help of this element, then again this 0 is getting destroyed. If I use this minus 1 to make it 0, then this 0 is getting destroyed. Okay, so whenever I'm trying to make something 0, some other 0 is getting destroyed. Okay, if I try to make this 1 as 0 with the help of this minus 1, I will end up destroying this 0. Okay, so with the help of this, if I make this 0, then this 0 will be destroyed. So the moment I'm trying to make something 0, some other 0 is getting destroyed. So that means I cannot make anything completely 0 over here. It's not possible. Okay, so that means this matrix has a full rank. Full rank means its order is 5 cross 5. Its rank is also 5. Full rank. Okay, now if some people are intelligent, what they can do? They can find the determinant value of this matrix. Now finding the determinant will be not difficult, because there are many zeros over here. So you can easily find the determinant, and what you will see, the determinant is non-zero. So determinant non-zero means full rank. Determinant non-zero means full rank, and in this case the full rank will be 5. So this can also be another process, but this is not a good process. You shouldn't directly start with this, because suppose in any question you get determinant equal to 0. If you get determinant equal to 0, you know your rank is less than the order, but how much less you don't know. Whether your rank is 4, is it 3, is it 2, you don't know. So then you will end up wasting time doing the determinant. This is applicable only when the determinant is non-zero. If determinant becomes 0, it is a waste of time. Okay, so here when you are getting an idea that maybe rank is becoming a full rank, then directly do the determinant, verify your determinant is non-zero, and say directly it is full rank. Okay, let's do another question. Now this is again a very simple question. You should just look at the question and tell me the answer. Okay, just look at the question, tell me the answer. All the entries are -1. Okay, all entries are -1. Now -1 is not important. The important thing is all entries are same. If a matrix has all same entries, what will be the rank of such a matrix? All same entries, then what will be the rank? Just take an example and think. Forget about 5 cross 7. Take a 2 cross 2. No, zero rank is not correct. Zero rank is not correct. Your concept should be clear over here. If I have an element matrix A, all elements have same element A. Rank is not zero. With the I can do some operation over here. R2 dash equals to R2 minus R1. I will get A0, 0. So one row is still remaining. You cannot do anything about that row, provided if A is non-zero. Okay. Now if you are taking a matrix like this, all the elements are zero, only then rank is zero. If a matrix has all elements zero, that is the only situation when rank will be zero. Otherwise, the rank is at least one. At least one. Okay. So now here it is saying that all the entries are -1. Okay, all the entries are -1. So -1, -1, -1, -1. So if you do this operation, -1, -1, 0, 0. So one row is still remaining. So rank will be at least one. Now here the question is saying 5 cross 7. Okay. So if you have a 5 cross 7, -1. So basically you have 5 rows and 7 columns. So 1, 2, 3, 4, 5, 6, 7. And 1, 2, 3, 4, 5, and so on. You have a matrix like this where all the elements are -1. So basically this row will be remaining. With the help of this row, you can make every other row fully zero, but still the first row will be remaining. So that means rank will be how much? Rank will be 1. Okay. So if every element of a matrix is created with the same element, provided that element is non-zero, then rank is 1. Okay, rank is not 0. All right. Okay, so let's do this as the last question today. Last question for today. The matrix is created in this manner. N is greater than or equal to 3. Aij equals to ij. Now we did a question like this before. Okay, remember today we did a question like this, that aij was created as I minus j whole cube. We did a question like this. Here the instruction is that aij is the product of the value I and value j. This is how the matrix is created. Then what is the rank of such a matrix? Let's see who can do this. Last question for today. See, I have told you before, last day also, whenever you have a generalized value, whenever you have a generalized n value, take a finite value and do the answer. What is the minimum value of n you can take? It is saying n greater or equals 3. So you just take n value 3 and create the matrix. So n3 means it's a 3 cross 3 matrix. So create the 3 cross 3 matrix using the condition that is provided. Aij equals to I into j. Use that condition and create the matrix. Observe the matrix, you will get the answer. So the first position is A11. So I into j is 1. Next A12. I into j is 2. Next A13. 1 into 3 is 3. Then next we have A21, which is 2. A22. 2 into 2 is 4. A23. 3 into 2 is 6, and so on. You will get the elements. Next is A31, which is 3, 32, which is 6, 33, which is 9. So this is an example of such a matrix where I have taken n value 3. Now what will be the rank of this matrix? With the help of this row, we can make this row and this row fully zero, right? If we do R2 dash equals to R2 minus 2 times R1 and R3 dash equals to R3 minus 3 times R1. Okay, if we do this operation, we will get 1, 2, 3, 0, 0, 0, 0, 0, 0. So rank is how much? Rank is 1. So option B is the correct answer. Okay. That's it. So let this be the last question for today. We'll continue again next week. Okay. Bye bye.